Alright, let's try this again. This is now the fifth time I've tried to make this video because I keep having a tickle in my throat and then a coughing fit. Here's hoping. So I'm going to show you guys how to use the inverse of a matrix to solve a system of equations. There's a little bit of backstory I got to give you guys because it's again something that I should have shown you in the last lesson, but since we're switching things up out of order. First thing is we need to take this system of equations and turn it into what's called an augmented matrix. It's pretty straightforward. So first thing is just going to take each of the variables like out of the system. So instead of 2x, we're just going to have a 2, and then instead of 2y, we're going to have a 2. Don't squish them together. So like 22 or something like that. Give it a little bit of space, and then we're going to have our 10. And then, so the next one we'll have negative 2 and x, and then negative 3 for the y, and then the negative 3 for the answer. And so it's called an augmented matrix because it has this little vertical line here. What that does is just separates the kind of the variable side of the equation from the answer side of the equation, the constant side of the equation. And so just remember that that's not a 2, it's 2 x's, and that's not a 2, that's 2 y's, and negative 2 x's and negative 3 y's. And so everything here is x's and everything here is y's. These are constants. So our goal, and I don't want you guys to write this part down, our goal is to take this matrix and rewrite it so it looks like an identity matrix. And so a 2 by 2 identity matrix, and we're just focusing on this part here. This 1, 1 here, and then 0, 0 here, and then as we do that work, the numbers on the other side here are just going to change, and however they change, we don't know. And so why we want that to happen is because that's not a 1, that's 1x. And that's not a 0, that's 0 y's. So we have 1x plus 0 y's, so x equals, and then whatever that number is. So now we know the value of x. And then now it's 0 x's plus 1y, so 1y is now that number. And so now we know what x and y are equal to once we can make it look like that. So that's why we want to do that. So we figure out how to do that. And so we're going to use an inverse to do that. And again, we're only going to look at the inverse of the 2 by 2 part of the matrix. So we're looking at the inverse here. So just ignore the answers for now. I'll come back later. So we want to find the determinant of that first. I'm not going to name this matrix like matrix A or anything else, so I'll just say determinant. So A times D is negative 6. I don't know why I didn't equal sign. Negative 6 minus, and then B times C, so negative 4. So that's going to be plus, so it's going to be equal to negative 2. So there is an inverse, okay, because that's not 0. I'm going to find that rest inverse in this space here, and then we'll come down here and actually use it. So just FYI. So I'm going to find the inverse. Again, I'm not going to name it, so I'm just going to write inverse equals. So 1 over the determinant, so 1 over negative 2 times, right? And this is where the numbers switch places, so the negative 3 and the 2 are switching places, and then the 2 here is switching signs, so it's becoming a negative 2. And then the 2 here is switching, the negative 2 here is switching signs, so it's going to have a positive. So it looks like those two swap places, but they didn't. So it's a coincidence. So we're going to do that distribution. And remember earlier I said that it might be easier to do the next thing if we don't reduce and leave all the denominators same. So I'm going to do that here. So I know and these are particularly easy numbers, so it really probably wouldn't matter either way. But later on when that number down here is a little bit nastier, it's going to make a difference. I'm just going to kind of stick with my suggestion from earlier. So negative 3 times 1 negative 1/2 is positive 3 halves. Negative 2 times negative 1 had to be positive 2 halves. We have negative 2 halves and negative 2 halves. All right, so we found the inverse. I'm going to go now use it. So I'm just going to bring that over here to this left side. And so what we're going to do with that is we're going to actually multiply that to what I'm going to call the answer matrix, which is this. So this little 2 by 1 matrix here, 10, negative 3. So that, all right, well, can we multiply these, right? So this is a 2 by 2, and this one's a 2 by 1. And so, those numbers here in the middle are the same, so this is doable. And the numbers on the outside, right, would tell us the answer is also going to be a 2 by 1. So we're going to end up with, another matrix that, the same size as this one. Essentially, we're done with it. So, again, I do want you guys to show your work, especially these fractions. It's going to be important. Again, leave yourself a little more space than maybe you think you need here. So I'm just going to make these a little bit more. There's not a ton of space in here. So we learned yesterday about multiplication. So we're going to take this row essentially times this column. So the 3 halves is going to multiply the 10. So 3 halves times 10. It may seem tricky. It's really not. 3 halves times 10. Remember, there's a 1 underneath the 10. So 3 times 10 is 30, and 2 times 1 is 2. So really the idea is that you don't need to worry about the 1 at all. It's just that 3 halves times 10 is 30 halves. Like, only these two numbers multiply. Most common mistake people make when they try to do something like this is they think the 2 also hits it with a 10. Well, if that was true, then we would reduce that and we get 3 halves back. I'd be saying that 3 halves times 10 is equal to 3 halves, which of course it isn't. So multiplying a fraction by a whole number should be very simple, even if it's like a horribly ugly fraction like 11 over 7 and times like 8. Like, well, it's just 88 sevenths. It's really simple. So don't get worried by that. So 3 halves times 10 is 30 halves. And then 2 halves times negative 3 would be negative 6 halves. We'll add those together. And then the next row is going to multiply that column. So we end up with negative 2 halves times 10. So negative 20 halves. And then negative 2 halves times negative 3. So positive 6 halves. That's what I add together. So why I wanted to keep the denominators the same, because it makes this addition here much simpler than if these, again, it would have been easy because these were like 1s or something like that, but 30 halves plus negative 6 halves is just negative 24 halves. And then on the bottom here, negative 20 halves plus 6 halves is just negative 14 halves. And so, of course, reducing those, we get negative 12 and negative 7. Not negative 12. We're going to get that negative 12. Sorry. 30 halves plus negative 6 halves is 24 halves. So that's positive 12, negative 7. So there's our x and y. X is equal to 12. And y is equal to negative 7. We could write it also like this. And, is that right? So we can go back and check. You should always check both equations. So you guys struggled with this on the quiz. So 2 times 12 is 24. And 2 times negative 7 is 14. Now 24 minus 14, that does equal 10, so it checks there. And then negative 2 times 12 is negative 24. Negative 3 times negative 7 is positive 21. Okay, negative 24 plus 21, and that does equal negative 3, so it checks in both equations. So there's an example of how I'm going to do that again with here. So first thing I want to do is rewrite my system of equations as an augmented matrix. So 2, negative 5, 10, 4, negative 5, 15, vertical line here. And when you're finding the determinant of that, you're just looking at this part here. So a times, determinant equals, so a times d, so negative 10. Doing this part, that part. Trying to do my colors here for you. So I get negative 10 minus, and then negative 5 times 4, so negative 20. Why does that change? So that would be plus, so that is equal to 10. And so then our inverse is going to be equal to, so 1 over 10 times, so 2 and negative 5 are going to switch, so I got negative 5 and 2, and then the negative 5 in the top right switches signs, so it becomes positive 5, and the 4 in the bottom left switches signs, becomes negative 4. And again, I'm just going to do this without changing any denominators, so negative 5 tenths, 5 tenths, negative 4 tenths, and then 2 tenths. So yeah, I'm going to leave all my denominators the same. That's 2 tenths. I'll bring my inverse over here. Negative 5 tenths, negative 4 tenths, 5 tenths, 2 tenths, times my answer matrix again, which I call that. So I'm going to go here. 10, 15. And then so I'm going to multiply those. And more space than we think you need. So negative 5 tenths times 10. Right? That'd be negative 50 tenths. Plus 5 tenths times 15. So 5 times 15 is 75. That's 75 tenths. And then negative 4 tenths times 10. So it'll be negative 40 tenths. And then plus 2 tenths times 15, so it'll be 30 tenths. Negative 50 plus 75 is 25, so 25 tenths. And then negative 40 plus 30 is negative 10, so we have negative 10 tenths. And 25 divided by 10 is equal to 2.5. And negative 10 divided by 10 is equal to negative 1. So we get 2.5, negative 1. Yeah, we're checking that. 2.5 times 2 is 5. Negative 1 times negative 5 is 5, so 5 plus 5 is 10, so it checks. And then 2.5 times 4 is 10. 5 times negative 1 is 5, so 10 plus 5 is 15. So it does check in both. So I know that my answer is right. Again, check both equations, not just one. So I think it should be good enough. I'll go ahead and do one more example just in case you do want to see it, but hopefully that's enough to help you get through the assignments on the Google Sheet. There are some other videos I've posted that I think are from other sources, so if you want to check those out, if any of this is something you're struggling with. So I'll just do one more example, and otherwise you guys can go on about your business. I'll see you guys next week. All right, so matrix 2, 1, 8, 1, negative 1, 10, line, determinant. Let's see, so we're doing this, negative 2 minus this, which is 1, which is negative 3. So the inverse is equal to 1 over negative 3 times, these two are going to swap places, 1, 2, these are going to both switch their signs, so they're both going to become negative 1. So distributing, I get positive 1/3, positive 1/3, positive 1/3, and negative 2/3. And then take that inverse, put it down here, 1/3, 1/3, 1/3, and 2/3. That's my answer matrix. So make sure we do the right order. So and we need our space. So 1/3 times 8, 8/3, plus 1/3 times 10, 10/3, and then 1/3 times 8, so 8/3, and then 2/3 times 10 is 20/3, so negative 20/3 plus negative 20/3. First, 8 plus 10 is 18/3. Negative 20 plus 8 is negative 12 over thirds. 18 divided by 3 is 6. 12 divided by 3 is 4, so negative 4. So 6, negative 4. And then 2 times 6 is 12, plus negative 4 is 8. 6 plus 4 is 10. So check, check. All right. If you stick around this long, thank you, and I hope you have a good, safe weekend, and find this to be not too difficult.